All right, our next topic, we are going to simplify radicals with any index. So that means we're talking about cubed roots, fourth roots, fifth roots, etc. So in order to do that, we really want to make sure that we know what numbers to look for. So what I've created is a table, and what I would do is copy this somewhere. You will need to have this readily available in order to calculate and do out some of these problems. And what we want to know is that our original numbers are all in gray here. So if we start with the 2, we know that we can plug it in to 2 squared, and we know it's 4. That means the square root of 4 is going to give us back our 2. So we can kind of work our way through this table and understand that if we take the cubed root of 8, we're also going to get back that original 2. So all of our simplifications are in the gray box right here. Everything that we're going to be simplifying comes all the way over here. So this is something we will reference and come back to throughout the lesson today. Now, we're looking for the cubed root of 250. So in order to do that, we want to start dividing 250 and find factors that will work for us. So we're going to make sure we're focused on our cubed root column, and we're going to do 250 divided by, and we want to recognize what actually will factor into 250. So I know that I could split 250 into the two factors of 125 times 2. And remember, this is the cubed root, so that has to be represented in each radical. Okay, so the same as simplifying our radicals with perfect squares, we're going to think the cubed root of 125, which is right here, is actually 5. So when we simplify this, the 125 turns into just a 5, and then we're going to rewrite the cubed root of 2 in our final answer. So this right here is what we would record for our simplest form answer. Now, 135, the cube root of 135, we have to do the exact same thing. So we do kind of have to continue to go back to this display. And when we're going through here, 135, we actually can divide by 27. So we know that we're going to use 27. 135 divided by 27 is 5. So if we multiplied 27 and 5, we would get back our original number. So we're just kind of splitting it into two factors and then simplifying. So the cubed root of 27, we actually are going to simplify that to just a 3, because remember, 3 times 3 times 3, right? 9 times 3 is 27. So that's how we're getting that 3. And then we're going to re-record the cubed root of 5 in our final answer, because we can't simplify that piece any further. Now, specifically, we need to look at the fourth root. So we have to change our thought process a little bit, and we have to change which column we're looking at. So now we're going to focus on the fourth root, and our problem is the fourth root of 80. So we need to think, what can we divide by 80? And we know that 16 times 5 will give us an 80. So we're going to break this into two factors, the fourth root of 16 and the fourth root of 5. Remember, we want to put out the factor that we can actually simplify in front. And so the fourth root of 16 turns into a 2. And we're going to re-record the fourth root of 5 for our final answer. Now, we are going to add in some variables, and I want to just share a couple of things with you. back when we were simplifying radicals, we said, okay, we can take the square root of a squared, and that equals plain old a. And what happens there is this 2 is being crossed out or canceled out with the square root because, remember, we can rewrite this as a to the 2 over 2, right? Exponent root, and that equals a to the first power. So that's the same thing for any root out front. If we have a root inside that matches the root outside, it's going to actually cancel to just a plain old variable. So what I'm going to do is I'm actually going to break this 162 into 2 numbers, and then I'm going to keep the fourth root of a to the fourth by itself. So we're actually going to have 3 different radicals here to start out. So 162. We want to go back to our fourth root column, and 162 is actually 81 times 2. So when we go back here, we're going to say 81 and a 2. Now, when we simplify this, the fourth root of 81 is equivalent to plain old 3. And we want to remember the fourth root of a to the fourth power cancel out to just an a. So the only thing we have left to record in our answer is the fourth root of 2. So that's our final answer. Now, there are 2 ways to approach this problem, and I wanted to show you because it's totally dependent on what you feel more comfortable with. So we actually learned maybe about a week ago, that we can rewrite this as n to the 6 over 3 power, right? 6 divided by 3 gives us n squared. So that right there is actually the final answer in this problem. We can't simplify it any further. However, if we go about with our roots, what we can do is actually break this into the cubed root of n cubed times the cubed root of n cubed. Because remember, the 3 for the 2 exponents, if we were to add those 2, we get back n to the 6th power. So when we simplify this, we want to remember that these 3's, the cubed root and the 3, cancel. So we just get an n. Same here, 3, or the root and the exponent cancel. So when we say n times n to the first power, n to the first power, we're going to add our exponents and end up with the same exact answer. For our last problem together, we are looking at the cubed root. So we do want to go back to that table at the beginning, but we can separate this a cubed into its own radical, and we want to separate 648 into what we can, so into 2 factors that will work for us. So we're looking at the cubed root column, and 648 can be divided by 216. So 216 times 3 gives us back 648. So when we write this out, I'm going to write the cubed root of 216 times the cubed root of 3 times the cubed root of a cubed. So now we're going to simplify what we can. We know that the cubed root of 216 actually simplifies to a 6. Okay, so we simplified that. We know that we can simplify our cubed root of a cubed to just an a. So we canceled that. And now we're going to re-record the cubed root of 3 in our final answer.